Gas fitter exam, cram session, video 22. Okay. Someone could say you have a water heater and, well, you know what? To save fuel costs, if I pipe hot water to it, it's that much less work it has to do to make the hot water hot enough. And it's like, you could do that, and then the money you think you're saving in fuel, well, you're going to be just putting it right back because you're going to be changing that water heater at least twice as often as you need to, because you heat water, it starts releasing the inherent minerals in it. It takes the minerals out of suspension. You're going to end up with a water heater that's going to always get caked up with a whole bunch of calcium and magnesium. It's going to fail you quickly, so that's why we don't do that. Okay, piping hot water to a water heater to a boiler just causes more problems. It just clogs everything up with mineral deposits. So there is no thing. It just doesn't exist. There's no good reason to pipe a water heater or boiler with hot water. And two, a water heater heats water to make it hot. So there is no such thing as a hot water heater. The minute you hear it, you know you're not dealing with a plumber. Okay? All right. Question 22. A fuel gas fired water heater or boiler may be replaced without a permit in an R3 occupancy. This is an exact repeat, so good, because this is an important number. This question has appeared. In an R3 occupancy, R3, R1, R2, R3, R3, 1-2 family, if 350,000 BTUs or less in capacity. We established that the code sees 350,000 BTUs as a small boiler. Small enough that we don't need a permit for that. As long as we don't move the valve, right? As long as the chimney's good, you know, we can swap out the boiler. We're okay. Or less in capacity. The appliance gas cock has not been moved and the plumber has found the chimney in good operational condition. So, 350,000 BTUs. That's our cutoff. The minimum depth of an appliance drain pan shall be, well, it's going to be the same depth as, remember, the appliance drain pan is the first pan under the appliance in case it lets go and starts spilling out the water. And we established that the code is that kind of guy that wears suspenders with a belt. The auxiliary drain pan is going to sit somewhere underneath so that in case the alarm for the first pan doesn't go off to let you know, oh, that pan's filling up, the second pan will get the overflow, and then that one will have an alarm, let you know, uh-oh, something's wrong. The dimensions are going to be the same for both. So if the auxiliary had 1.5 inches depth minimum, so will the appliance drain pan. 1.5 inches depth, correct? All right. Vent piping. We're on question 24 now. Vent piping for high pressure devices shall be sized the same as the tappings provided by the manufacturer. We'll take a couple of seconds on this one. This is important because this one is in the appendix for high pressure gas piping. So high pressure gas, we said, is 15 psi or more. High pressure gas is covered in an appendix. The appendix for meter piping was E. So the appendix for high pressure gas, and there's only 2 letters, E and G. High pressure gas, gas, G. Appendix G. So in high pressure gas, we're going to deal with vent piping for high pressure devices. Devices, so they didn't even say regulators, but regulators, vent limiting devices, relief devices. There's going to be a lot of fail-safe mechanisms for high pressure piping and the mechanisms that go with it. When you're, let's say you have these relief devices, they relieve excess or overpressure of gas. They're located in rooms, mechanical rooms, boiler rooms, etc. They're going to relieve the gas. They can't relieve it there. It's going to be piped to the outside, just like we do with regulators in our standard meter rooms. What size are you running the vent piping? In this case, you're just going to go with the tapping on the device itself. We'll take a regulator because that's easy. Let's say we have a regulator in a high pressure system and it's got a relief port, and we're going to pipe that pipe from the relief port to the outside air. What size is it going to be? I don't know. What size tapping is on the regulator? In this one here that I'm holding in my hand, the size of the tapping is going to be 1 inch. And that's what you're running, 1 inch. I got another device here. You know, this is a pressure relieving device off a valve or something here. This one, the manufacturer says we also have to run a relief pipe to the outside air. What size do we need to order the piping? I don't know. Look at the tapping. I'm looking at the tapping, and this tapping, ooh, that looks pretty big. That looks like 1.5 inches. You know, I mean, I don't know. It's like that's pretty big. I mean, maybe we could just bush it down to 1 inch since we're running 1 inch here and we just order 1 inch. No. The tapping, as it came from the manufacturer, is 1.5 inches. Guess what? That relief piping to the outside air is going to be 1.5 inches. The tapping on the device itself is telling you exactly what the size is. So, for this question, and this question is from the high pressure gas appendix, Appendix G, vent piping for high pressure devices shall be sized the same as the tappings provided by the manufacturer. Question 25. A gas service line valve shall be, okay, we established that the gas service is the piping from the main to the basement or cellar or to the meter set. It's the supply. It's the same thing as the water service is the pipe between the main and the street and the control valve in the house. The gas service line valve is same principle. There's the gas main in the street and then the service running to the control valve in the house. This control valve we call the gas service line valve. Shall be, in respect to the meter, upstream of the meter. Once again, you're not going to get away from upstream, downstream. Okay? What is the flow? The flow is from the main in the street through the service to the service line valve. From the service line valve, now we have our meter set. From the meter set, the outlet, point of delivery, is the distribution piping to the most remote outlet. Okay, so if the flow is going this way, and we had the main, the service, the valve, the meter, the distribution, then we know the meter is downstream of the valve. The valve is upstream of the meter because the flow of the direction of flow. So a gas service line valve shall be upstream of the meter. You got to get used to that. You know, if it was just us in the basement laying out the work or say blah blah, say yeah, it goes before the meter. We understand what we're talking about. Okay, but for the test, yeah, it goes before the meter. Oh, okay. Well, in this case, it's upstream of the meter. Where does the meter go? The meter goes after the service valve. Well, then in that case, according to the test, the meter is downstream of the service valve. Upstream, downstream. Keep that. Always keep harping on that in your mind because that's the wording they love. You're going to see that often in the exam. And a lot of guys, they came back, that threw them off a little bit too, So, if you start getting used to this, treat it like you're learning a second language, and now you know how to say, where is the restaurant? In whatever language, you're going to eat a lot better in whatever place you're visiting than the person who didn't learn where is the restaurant, right? Okay, upstream, downstream. 26. Conduit for underground gas piping beneath buildings shall extend not less than how many inches outside of the building? We had this question before, but we asked conduit for piping we're running underground of a building. When the piping extended to the floor, the conduit had to extend at least 2 inches. But didn't I tell you 2 inches? But we're also going to have situations where it's coming out of certain places. In this case, the conduit for underground gas piping beneath buildings shall extend not less than how many inches outside of the building. When we're outside of the building, and we're talking about coming out of the wall, right? It's not going to extend less than 4 inches outside of the building. Okay, so 2 inches up from the floor, 4 inches outside of the building. Okay, so you can imagine this possibly could be meter piping outside the building. You know, somehow it goes back in and goes down to go back around, feeding or whatever. Somehow, somewhere, it's one possibility, but somehow, someway, you got the piping extending outside, and it was running through a conduit because it had to if we were going to run it underneath the building, underground. That sleeve's got to extend 4 inches, not 2, 4. 27. Of the following, the joint allowed within a gas distribution system is, okay, I'm going to say right now, D, welded. Okay, we're allowed welded. Only because now let's concentrate on the 3 things we should not use, all right? 1, threaded with lampwick. You saw lampwick immediately. Lampwick, no, absolutely not. Flared, not allowed a flare joint, okay? I know it's weird, like I said, a flexible connector is a flare joint, okay? But you're not allowed a flare joint. And like I said, the code's going to do whatever it wants. It says it's none of its business. Well, you know what? It's going to say, well, we didn't say the code covered that. Then again, they're going to say, well, you can only have a 6-foot flexi. And it's like, but you say you didn't care about that. I say, well, we changed our mind, you know? You can't fight City Hall, right? Okay, so no lampwick, no flared, flanged, but with a reused gasket. No, we said you can't do that either. The minute you break open that flange joint, doesn't matter how lucky you got. That gasket's coming off, you gotta put a new one. Every time you open that joint, you have to use a new gasket. So, lampwick, no good. Flared, no good. Gasket, can't be old. New gasket, not new gasket, no good. So, A, B, and C, no good. D, welded, of course. I mean, we've spent a great deal of time talking about welding in the gas system. 28. The test pressure for a gas piping system with an operating pressure of 5 psi. So, we knew 5 psi was a cutoff. 5 psi in our mind's eye, that's that second level. So I'm already thinking like, well, I remember half and 5 were together in some way. I knew they both share 30 minutes. But I knew where half automatically says 3 for 30. 5 is not 3 for 30. I know it's for 30, but 5 is 50 for 30. So let's see if I'm right. Test pressure for gas piping system with an operating pressure of 5 psi shall be 50 psi for 30 minutes. 50 for 30. Okay? 50 for 30. And you see how I tweak, because the answer choice is here. That's not how you're going to see it on the test. But once again, I tweak it that you can practice your numbers, because if you've been practicing your numbers with memory, shorthand, 3 for 30, 50 for 30, 100 for 1, in this case, minutes, so it's 60 minutes an hour, and then 2 times, for an hour. It's like, okay, but now you have to remember what goes to where. You have the numbers right, but what goes to where? 3 for 30 for half, 50 for 30 for 5, 100 for 60 for 15, double the maximum, or 2 times for 60 for an hour, kind of implied. That's for over, over 15. Okay. All right, question 29. Wow, that's amazing that we got the same question twice. But you know what? Let's do it. A fuel gas-fired water heater boiler may be replaced without a permit in an R3 occupancy, 1-2 family, if 350,000 BTUs or less in capacity. The appliance gas cock has not been moved, and the plumber has found the chimney in good operational repair. Once again, 350,000 BTUs is a small boiler by code standards, no permit necessary. 30. The only allowable location for a test tee or drip leg is downstream of a lockable supply valve. Okay? Now in here, this particular test tee or drip leg they're talking about, we've talked about a sediment trap, we've talked about a union. They all have to be downstream of the appliance shutoff valve. Now here, this test tee or drip leg, this is not necessarily before an appliance. This is not necessarily dedicated to a single appliance. In here, this may be dedicated to a riser or some piping serving a certain section. This piping serving this certain section, like a riser is the most common example. We're going to have a lockable supply valve, not just a shutoff valve, but a lockable shutoff valve, a lockable supply valve, so that in case of emergency, this valve can be closed and the utility can put their own special little lock in there so that no one can open it. Okay? In that case, this test tee and drip leg, this must go after that valve, because once again, anything pertaining to that, whatever the valve is shutting off, anything pertaining to that, in this case we'll say a riser, must also be isolated. It must come after the valve so that the valve shuts that off too. Okay, so I guess a little picture. Let's see, we'll have our horizontal main, and we're taking off, 2 elbow swing off of the horizontal main. For a branch, this branch is to a riser. Okay, here's the drip leg, here's a test tee, all right, and here's our lockable supply valve. The test tee is plugged. This test tee is, well, it's going to be used exactly for what it says. It's a test tee. It's a tee where, you can shut your valve, isolate the riser, use this tee to hook up your testing equipment, put a test on it, and then the drip leg at the bottom of the riser, we said, for wet gas, it's definitely there to collect condensate. Just for, in general, over time, scale has a place to collect. Initial installation, oil and chips has a chance to collect. But because we don't run wet gas anymore, and mainly because the utility wants to avoid any possibility of a connection, any illegal connections to the gas, we don't have these drip legs anymore. We just use an elbow at the riser. Now, you're also going to say, well, isn't the test tee? Didn't you just say there's a test tee in there with a plug? I mean, can't I just run an illegal connection off that? You could, but they already are one step ahead of you in that test tee, that outlet is 1/2 inch and gets plugged with 1/2 inch. Usually your illegal connection, you're trying to run a new stove. Your stove has to have at least a 3/4 valve because the stove has a minimum required supply, BTU supply, BTU per hour supply it's going to need. that's not going to happen with a 1/2 inch connection. So it's sized 1/2 inch to discourage you from trying to connect the stove. Not much else you would connect, so they leave it like that. But regardless, the test teeth, the drip leg, anything that has to do with this particular riser or section that you would feel the need to install a shutoff just in case you have to isolate it, well, everything's got to go downstream of that lockable supply valve. Question 31. The maximum spacing for 1/2 inch horizontal gas piping is, well, we had 1/2, then 3/4 and 1, then 1.25 inch, which is 1.25 inch, anything above it, and then we had our cadence. Our cadence was 6, 8, 12, 6, 8, 12. Well, 1 inch is the first, 6 is the first, so I would say 6 feet. The maximum spacing for a 1/2 inch horizontal gas piping is 6 feet. The maximum spacing for 3/4 inch horizontal gas piping is, well, 1/2 took the 6, 3/4 and 1 take the next number. 6, 8, 12, 6, 8, 12, so 8. So, this time I get it right because I think I got this question wrong last time in the last exam, in the last test we were going through, but now I'm positive. It's got to be 8. The maximum spacing for 3/4 horizontal gas piping is 8. Good. And I'm glad, for a second I got scared because I said, oh, I hope I read horizontal because I saw every floor and I said, oh no, did I make the mistake? Did I just skipped over vertical, think it's horizontal? But no, but if it had been horizontal, we know, if it had been vertical, we know, doesn't matter, every floor. Okay. 33. Gas service piping below a driveway shall be buried not less than. Okay. If you jump too quick, you might get the wrong answer because I remembered something about a driveway, but did I remember it correctly? Well, I'm going to say it's easy to think you remember something because you see the words or whatever, but I know that the blanket statement is gas piping is going to be buried 24 inches deep. But it can be 18 inches if it's not underneath the driveway and I protect the property. If it's not underneath the driveway. So what does the question ask? Gas service piping below a driveway. Oh, well, this is exactly where I can't enjoy just digging an 18-inch trench. Now I got to dig the full 2 feet. Okay? Below a driveway shall be buried not less than 24 inches below grade. Do you see how they changed, how they can give you a question that kind of makes sure that you, one, are reading the question, and two, that you learned the code for what the code says. You know your numbers, but do you know how to apply the numbers? Here, I double check. I said, wait a minute. I know I can get 18. I know it had something. I know something about a driveway, but what it was 18, but not under the driveway. That's the one place I can't do it. And now they're asking, well, that is the place you're putting it. Say, oh, well, then I got to put the 24. And I think I took it easy on you because I didn't give you the 18. You know, I think, I kind of let you get away with, I think around this time maybe you should, I should have challenged you a little more and put 18 as choice A just to see who would fall for that one. Okay? Yeah, that was too easy because 12, I'm pretty sure none of you would bid at 12. And 24, yeah, this was kind of a giveaway. For this kind of question, you know what? Next time I think I'm going to put 18 in there because I think I can catch a lot of guys with 18. I think they would pick that. Not taking the time to think, right? Question 34. Fresh water may be used as a test medium when the required test pressure exceeds 100 psi. So if we're testing at 101 psi, we can use fresh water. But there was another kind of big number that was in addition to in addition to our gas test pressures. What was that other number? That was 90. And what about 90? Well, 90 psi is the minimum pressure we're going to use to test coated and wrapped piping. Generally, we're talking about the service line. Question 29. Wow, we've been getting this question a lot. Unless incorporated as part of a gas burning appliance, a sediment trap shall be installed downstream of the appliance shutoff valve. Just like everything else associated with that particular appliance that valve is meant to isolate, it's all going to be downstream of the valve. Okay, here's the question. Question 36. Coated and wrapped piping shall be tested at a minimum of 90 psi. Question 37. Let's see if we remember. Because we touched upon this, and this one's a little bit of a beast, but we take our time, we can tame it. Gas piping shall not be installed in public corridors and exit enclosures, except at the lowest level, call it the lobby, right? And all of these apply in residential buildings, apartment buildings, condos, that do not have floors below grade. We don't have a basement or cellar. When gas pressure within the corridor gas piping does not exceed half a psi, so stoves and all the piping is welded. We went through a whole thing of we're not going to go through that again, but we went through a whole thing of, well, it's welded, and also remember we had to test it at 10 psi for 30 minutes, where the rest of the system by code only needs 3 for 30, and the logistical weirdness situations that, you know what, that's interesting. That's interesting when it comes up, right? Okay. And the next question. Testing pressure for public corridor piping shall be 10 psi for 30 minutes. Not 3 for 30, 10 for 30. In this particular instance of public corridor piping, that is also all welded. An interesting situation. Question 39. This is a lot of repeating, but then the test repeats itself a lot. Okay, doesn't hurt to go over it again. Question 39. When an appliance is installed on a sloped roof with an edge of more than 30 inches above grade, a level platform shall be provided for servicing at each side requiring access. In addition, the handrails at 42 inches high shall be provided. 42 inches high shall be provided. Question 40. When located in, it's almost strange. I'm just going to check for a second. I know it's almost like we're doing this all over again, right? Just want to double check. No, it's actually repeating. All right, well, it's there. Let's do it. When located in a public corridor or exit enclosure, gas piping shall not be installed in a return air plenum. Return air plenum for the mechanical system, for air circulation. And also we established that it's not going to be installed in, well, if we turn to page 30, that question showed up again. Gas piping shall not be installed in or through a furnace plenum. And we said the furnace plenum, we could consider it, consider it the manifold on top of the boiler. Well, the furnace is it's a boiler for hot air, a hot air system, forced hot air. That plenum is just the big section of ductwork sitting on top of the boiler. The manifold, say, for the distribution ductwork. So we're not going to install it in or through a furnace plenum. Question 42. Okay, see, now we're getting to different questions. So